This is the final video for section 6.4, which is all about rational equations, and the final video for chapter 6 about rational expressions and equations. This video is going to focus on a couple of specific kinds of application word problems that tend to give people a lot of trouble. These are broad categories, so there are going to be a lot of variations within these types of questions. So this is really just going to be me trying to set you up for knowing kind of how to approach these things. So rational expressions, again, are fractions. All right, that's something we've talked about a bunch. And fractions tend to pop up a lot of the time in situations where we're solving problems that involve rates. So if you don't remember, because that's something that you might not have seen since grade 8 or grade 9, although it should have popped up also in grade 10, a rate is a comparison between two quantities. And typically, for us especially, it's going to be a comparison between the change in two quantities. And so our first type of problem is going to typically look something like this. So we've got Maria, and Maria can dig a hole on her farm in 3 hours. All right, we don't know what the hole is for, but it doesn't matter. Her friend Jenna can dig a similar hole, right? So maybe they need a bunch of them. In 4 hours. So Maria's a little bit faster. And so what I want to know is how long would it take for them to dig one hole if they were working together? And so this is the first broad category of these kind of questions that you're going to run into, where it's some kind of task that can be done in different lengths of time depending on who's doing it, and then you're trying to sort of boil that task down into one amount that's shared between two things. So these questions typically are going to kind of task us to make a table so that we can organize things. So you're often going to hear me, if I talk about these, call these table questions, because the table is really the hardest part of the question. So let's lay out what we know. We've got two people, Maria and Jenna. So that's going to be our first column. So Maria and Jenna. And then we know the time that it takes them to dig one hole. So for Maria, that's going to be 3 hours, and for Jenna, that's going to be 4 hours. And that's sort of all we have. But we also want to know about them working together, so we're going to throw both in there as a third row. And we don't know that amount, right? We don't know how much they can do together, so we're just going to leave that as a variable, because that's the thing we want to find out, so that's going to be t. So before we kind of progress to our next step, because our table is going to have another column, let's think about that for a second. So if we have a hole, right, hole looks something like this. For Maria, it would take 3 hours to dig this entire hole. For Jenna, it would take 4, but we're not going to worry about Jenna right now. She's too slow. So what might be useful is to ask ourselves, well, okay, how much can they do just in 1 hour? So that's going to be our third column. So we've got their names, we've got how long it takes them to dig, and then how much they can get through just in 1 hour. Because then the issue with what we started with is you can't add the times together. If it takes one person 3 hours and one person 4 hours, you can't just say, oh, okay, well, 3 plus 4 is going to be 7, because that doesn't make sense. Two people working together should go faster, not slower. So when we're doing these equations, typically we're going to try to get ourselves to a point where we can combine two things to get a third thing, whether it's by adding or by subtracting, or where we can get two things that are equal to each other. So we can't add up the time it takes them to dig, but we can add up how much they dig, right? So the amount that I dig and the amount that you dig together would be the amount that we dig total. So per hour, if it takes Maria 3 hours to dig that hole, then if we split that up into 1 hour chunks, then in each of those hours, she has dug 1/3 of the hole. And so coming back over here, then we'd say, okay, well, if Maria takes 3 hours to dig her hole, then per hour she's going to dig 1/3 of the hole. If Jenna takes 4 hours to dig her hole, then every hour she's going to dig 1/4 of it, right? Every hour she gets 1/4 of the way there. And then following that same logic, where we go from 3 to 1/3 and 4 to 1/4, then both of them combined should be 1/t. Right? So whatever that time is. So if it took them 2 hours to do it together, then, well, after an hour, they'd be halfway there. And so these three things at the end here, these we can make an equation out of. And the reason that we can make an equation out of this is that the amount that Maria digs plus the amount that Jenna digs should be the amount that they dig together. So 1/3 plus 1/4 equals 1/t. And now we just need to solve this. All right, so this is a rational equation, and we're going to solve it just like any other rational equation. So the same thing we did in the last two videos in section 6.4. Our common denominator here is 12t. And so to make this solvable, my first fraction needs to get multiplied by 4t. My second fraction needs to get multiplied by 3t. And my third fraction needs to get multiplied by 12, which is going to leave me with 4t over 12t plus 3t over 12t equals 12 over 12t. All of my denominators match, so I can get rid of them. So now I've just got 4t plus 3t equals 12. If we combine those like terms on the left, 4t and 3t gets me 7t equals 12. And now we can just divide by 7, which gets me my final answer of t equals 12 over 7, or probably a little more helpful for this question, 1.71 hours. Which makes sense if you think just in terms of the context of the question. So it takes Maria 3 hours. If there were two people going the exact same speed, they both took 3 hours, well, then they'd get it done in half the time. It would take an hour and a half. But since Jenna's a little bit slower, it takes them a little bit longer. And 1.71 hours seems like a pretty reasonable answer. We do need to worry about NPVs. So in this case, our NPV is just t equals 0. And there we are. So this is the first type of question that you're going to run into. And they're going to be solved pretty much the same way. So where you're going to take a time to do something, you're going to turn it into an amount per hour in this exact same way, right? Just 1 over however many hours it takes. And then you're going to add those together to get your third thing. The second type of equation is going to be a little bit different. So let's get this going. So, looking through this, we've got Emily. Emily is driving to Calgary and back, and it took her 22 hours. The weather was a little bit different in one direction than the other, so on her way there, she was able to go 10 kilometers per hour faster than she did on the way back. We're told that Calgary is 1,000 kilometers away, and we want to know what her speed was. So before we can get into this, the most important thing to know is that speed is just distance divided by time, right? Kilometers per hour, meters per second, whatever. Speed is distance over time. If you've taken physics, you might have been shown this triangle, where we basically just take those letters, speed is distance over time, and we just put them inside of a triangle like so. But the important thing about this triangle is that it can also help us figure out other things. So if speed is distance over time, we can go a different direction and also say that time is distance over speed. And that's going to be super helpful for us in this equation. So we're just going to say right now, time is distance divided by speed. So this is the other type of question you're going to run into. One of them was those fractions per hours. The other one is almost always going to be a speed question. So speed, distance, and time. It might be phrased slightly differently, but the process is going to be basically the same. So our trip involves driving to Calgary and back again. So we've got there and back. We've got speed. We've got distance. And we've got time. So, some questions will just involve a there and a back, or a first half and a second half, whatever. Some questions do involve a total. So we have to look at this question to see if total is relevant. And it is, because we're given a total time up here. This time, 22 hours, is the total driving time. So we weren't told it was 10 hours there, 12 hours back, or something like that. We just have a total to work with. So we do need to have a third row here for total, but that's not always going to be the case. So don't just automatically add total in here. Make sure a total is actually relevant to your question. All right, so let's start filling in what we know. So going back up here, like we've already said, we've got 22 hours. We're also told that Calgary is 1,000 kilometers away, so that's also pretty helpful. And we're told that thanks to the good weather, she was able to drive 10 kilometers per hour faster on the way there than on the way back. So all of that is going to be pretty helpful to us. So let's start filling some stuff in. The easiest thing to fill in is our distance. We're told Calgary is 1,000 kilometers away, not 1,000 kilometers total, just 1,000 kilometers away. So our distance is 1,000 on the way there, 1,000 on the way back, and we do know a total distance, right? Because you can just say, okay, 1,000 there plus 1,000 back is 2,000. So we could technically make an equation out of this. It would just be a very boring equation of 1,000 plus 1,000 equals 2,000. So there's not much going on there. For our speeds, there's no such thing as a total speed, right? You can't combine speed on the way there and speed on the way back. So that total in the bottom left just is meaningless. And then we do know a total time, which is 22. So looking at the question, to get a sense of what your variable should be, look at what you're asked. We are asked to figure out what was her speed in each direction. So speed is what we're looking for, which means our variable should probably be s. So we're going to say s is speed. But we also have to take into account that bit about the weather. So she drove faster by 10 kilometers per hour on the way there than she did on the way back. So we can't just say these are both s, because she didn't go the same speed in each direction. So if she went 10 kilometers per hour faster on the way there, then the best way to handle that would be to do s plus 10 on the way there. So we're not going to use different variables. We're just going to adjust one of the variables to fit with what we have. Do make sure you recognize the difference between going a certain amount more and a multiplication. So if I say 5 more, that just means plus 5. If I say 5 times more, that means times 5. So you've really got to get the difference between those. So we've got our speeds. The last thing we need is time, because we're not going to be able to make an equation out of speed, right? The speeds do not connect directly. We know one of them is 10 more than the other, but we don't have a total. We can't make an equation out of them. But just thinking in terms of time, the time on the way there and the time on the way back, if you add those together, right? So say if it was 12 hours one way, 10 hours the other, those do have to add up to your total time. So we can make an equation with this time column. To figure out what to put in the time, we're not going to use another variable. So you don't want to have multiple variables in these questions. what we're going to do instead is we're going to go back up to this triangle here and these two equations. So speed is distance over time. That's great, but not super helpful to us. But this one on the right here, time is distance over speed. So if we go back down to our table, I have some distances and I have some speeds. So my time on the way there is our distance on the way there divided by my speed on the way there. And then same thing on the way back. So 1,000 over s plus 10 and 1,000 over s. And so now these two things can help me make an equation. So my time on the way there, 1,000 over s plus 10, plus my time on the way back, 1,000 over s, has to equal my total time of 22. So just again to kind of set you up for looking at some different kinds of questions, there will often be cases where you are adding like this. So we're doing our s plus 10. Sometimes you might be adding and subtracting. So it might be s plus 10 one way, s minus 10 the other way. Sometimes you're going to be adding up to a total, but I could have also said it took her the exact same amount of time to get there as it did on the way back. And in that case, you'd have two things that are equal to each other instead of having them adding up to something. So you've got to keep track of these things. Just do what makes the most sense in the context of your question. Anyways, we now have our equation that we can solve. Our common denominator is going to be s times s plus 10. So we're just going to solve this the way we should. So go ahead and try to solve this one yourself. So get your common denominator on everything. Go through the whole process. You will have to use the quadratic formula on this one, just so you know. So don't even bother trying to factor it just because the numbers are going to be ridiculous. And then come back and see how you did once you're done. Do make sure your answer makes sense. All right, so my first fraction is missing the s. My second fraction is missing the s plus 10. Oops. And then my third fraction is missing both of them because it doesn't even look like a fraction right now. So if I get rid of those denominators because they all match and do some multiplication, I'm left with 1,000s plus 1,000s plus 10,000, right? Because I've distributed this 1,000 through. And then on the right side, if I multiply the stuff outside of the brackets, I get 22s, and then I still have that s plus 10 to deal with. So I can combine some stuff on the left. 1,000s plus 1,000s is 2,000s. 10,000 is just 10,000. On the right, if I distribute, I get 22s squared plus 220s. This is quadratic. We've got an s squared over here. We want to move everything to the same side. We're probably best off moving everything to the right. So when you do that, you're going to get 22s squared minus 1,780s, because we did minus 2,000s on both sides. And then minus 10,000, because we also subtracted 10,000 on both sides. So again, this is not something you're even going to want to consider factoring. The numbers are way too big, and it isn't actually factorable. So we're going to go to the quadratic formula. So we've got s equals negative b, so that's 1780, plus or minus the square root of negative 1780 squared minus 4 times 22 times negative 10,000 all over 2 times 22. Which is going to get me 1780 plus or minus. And so if you do all of that stuff inside the root, you're going to get 4,048,400 all over 44. And so your two answers that you're going to get out of this are either s equals 86.18 or s equals negative 5.27. We're going to reject that second answer because, one, it doesn't really make much sense for them to be going backwards at 5 kilometers an hour, and two, there's no way you're going to be able to cover 1,000 kilometers in however many hours if you're going 5.27 kilometers per hour. It's just not going to happen. So to answer our question, all the way back up here, we were asked, what was her speed in each direction? So we're not actually quite done. Some people are going to get this 86.18 and stop, but that's not the final answer to the question. So we had a speed on the way there, which was s plus 10. So that's going to be 86.18 plus 10, which gets us 96.18 kilometers per hour. And then our speed on the way back was just s, so that's just going to be the 86.18. So you got to make sure you're actually answering the question when you're done. Our NPVs, our s cannot be 0 or negative 10. And so there you have your other kind of word problem that you're going to see in this chapter. It's either going to be those fraction per hour questions, or it's going to be a speed, distance, time question. So make sure you brush up on these. And if you're having trouble, ask questions, get some extra help, and do practice. There are lots of these questions in your textbook, so make sure you check out your textbook and try these, because there are many different ways these things will work. And if you only understand how to do these two specific cases, you're never going to know how to adapt to other things. So that wraps it up for chapter 6. So once you're done and you've really solidified your understanding, feel free to move on to another chapter.